You're listening to ARC Advisory Group's The Sustainability Podcast, where we explore how artificial intelligence, industrial sustainability, logistics, supply chains, and smart cities are shaping the future. In every episode, we talk with industry leaders who are finding practical ways to create more sustainable solutions. Whether you're a business professional or just curious, these conversations will give you fresh ideas on how to reduce environmental impact while improving efficiency. From smart technologies to rethinking supply chain strategies, there's always something new to learn. If you'd like to go further and make a real difference, be sure to connect with ARC Advisory Group. Our expertise can help your organization adopt cutting-edge sustainability strategies that drive both innovation and results. Don't miss the chance to stay ahead and make meaningful changes for a more sustainable future. The economics of space freight, reducing costs, addressing challenges, and defining future logistics. Space freight is becoming more accessible, offering a new dimension for logistics operations. Companies such as Elon Musk's SpaceX, Jeff Bezos' Blue Origin, Rocket Lab, and others are lowering launch costs dramatically. SpaceX has achieved approximately a $2,600 per kilogram to low Earth orbit cost, compared to roughly $16,000 or $17,000 per kilogram during the space shuttle era. Despite these reductions, the industry does face some complex economic, regulatory, and technological challenges that impact its scalability. For logistics professionals, the cost and limitations of space freight require careful evaluation to determine practical applications. A nuanced understanding of these elements is truly critical for informed decision-making. Let's examine current costs, challenges, and potential strategies, and then offer a realistic perspective on the possibilities of space freight logistics. First, the current space freight landscape. Today, that ecosystem includes both private companies and national programs working to establish a reliable infrastructure. SpaceX's reusable rockets, like the Falcon 9, have reduced per launch expenses to around $2,600 per kilogram to low Earth orbit, although missions beyond low Earth orbit still involve much higher costs due to the need for additional propulsion and environmental shielding. Telecommunications, defense, and environmental monitoring are sectors benefiting from these cost efficiencies, though deep space missions remain largely experimental and very expensive. Though space freight infrastructure is expanding, it does remain limited currently to a few operators with substantial capital. Broadening access to smaller organizations will require continued reductions in cost and improvements in efficiency. So what are the key challenges in space freight logistics? One is cost and reusability constraints. While reusable rockets have brought down costs, refurbishment still involves considerable resources for inspection, maintenance, and upgrades. For example, the current costs for those private space launches range from, as we had previously mentioned, $2,600 to maybe $10,000 per kilogram, depending on the mission, which of course poses a barrier for smaller and frankly many other organizations. The materials and engineering involved in refurbishment reduce costs only incrementally. This limitation suggests that further technological advancements are necessary to make space freight accessible for a wider range of operators. Without such advances, entry into the market will remain largely restricted to companies with significant financial and other resources. Regulatory complexity. Space freight involves navigating diverse regulatory frameworks, as each country sets its own policies and standards. The U.S. requires extensive satellite launch approvals, adding time and expense to the process. Internationally, the absence of unified regulations on satellite congestion, space debris, and resource use adds further complexity. This fragmented regulatory landscape complicates planning and increases compliance costs. A more consistent international regulatory framework could streamline all of these processes, helping reduce time and expenses associated with compliance. Until then, companies, particularly newer entrants into the ecosystem, will continue to face challenges with regulatory hurdles and all the uncertainty that they do bring to the process. The increase in satellite deployments also is creating congestion in orbit and raising concerns about space debris. Collisions generate thousands of fragments, which can damage or destroy active satellites. Current technology for debris management, such as laser-based deorbiting and tug satellites, is still under development and not yet widely available. Until effective mitigation measures are in place, debris remains a significant operational risk. Addressing this issue will require continued investment in research and collaboration to develop reliable solutions, as well as industry-wide commitment to managing debris responsibly to maintain safe and sustainable operations. Now, on the subject of deep space flight, and specifically the feasibility of deep space flight, while low Earth orbit missions have become more affordable, missions beyond low Earth orbit, such as those to geostationary orbits or even to Mars, involve higher costs and complex requirements. Deep space missions require advanced propulsion, radiation shielding, and life support systems, which add to overall costs. Current estimates for missions to Mars, for instance, exceed $100,000 per kilogram, limiting participation to only a few well-funded organizations. Developing cost-effective systems for deep space logistics will require significant investment and collaboration. But until these technologies are more affordable, deep space freight will remain financially out of reach for most companies. Supply chain dependencies and vulnerabilities. Space freight operations rely on specialized supply chains with high-quality standards, making them vulnerable to disruptions. Each component undergoes rigorous testing and certification, and delays in a single part can impact entire projects. Companies that vertically integrate production, as SpaceX has done, are less exposed to these vulnerabilities, but smaller firms face greater reliance on external suppliers. One bright spot is that additive manufacturing offers the potential to increase flexibility by producing components on demand, but current costs and certification requirements mean its use in space logistics is still a bit limited. So what are some potential strategies for progress? Well, investing in autonomous reusability and maintenance. Reducing maintenance costs for those reusable rockets could involve automating inspection and repair processes. Autonomous maintenance systems for in-orbit repairs could help extend the vehicle lifespan and reduce the reliance on ground-based maintenance. Partnerships between public institutions and private firms may be necessary to drive this research. Over time, these solutions could enable smaller companies to participate more fully in space freight if they become economically viable. Unified regulatory standards. Developing international standards for satellite licensing, collision prevention, and debris management could reduce regulatory complexity. Consistent rules across countries would allow for simpler compliance processes, helping reduce project timelines and related costs. Creating working groups within industry and with government representatives may be one way to achieve these standards. Of course, for smaller organizations, unified regulations could reduce administration challenges and speed up market entry. Debris mitigation. Investment in debris mitigation technologies, such as the tug satellites and in-orbit recycling, is important for maintaining safe orbital operations. Public-private partnerships could help develop these technologies and make them available industry-wide. Focusing on debris management could reduce collision risks and associated insurance costs, improving operational conditions for space freight. Continued R&D, and more specifically funding in this area, will be necessary to implement effective solutions. So what's the future look like? Well, in the long term, space freight costs may continue to decline as technology improves and economies of scale develop. Some industry estimates suggest that costs could decrease to $1,000 per kilogram to low Earth orbit over the next decade, potentially opening up access to more industries. In-orbit manufacturing and autonomous systems could further reduce costs, while increasing operational flexibility. This future of space logistics will likely depend on advances in both technology and regulation together, requiring industry stakeholders to keep track of operational developments. And as these costs decrease, applications such as global internet networks, as we're starting to see, and satellite constellations could expand, making space logistics a more integrated component of global operations. Thank you for tuning in to the Sustainability Podcast. Today, we explored how artificial intelligence, logistics, supply chains, and smart cities are revolutionizing sustainability efforts across industries. Now's the time to take what you've heard and start implementing those changes in your work. Please share this episode with others who are passionate about building a better future and keep the momentum going. For those looking to go deeper, ARC Advisory Group offers unparalleled guidance in developing and executing sustainability strategies. Please reach out to us for expert insights and support that can help you turn these ideas into action and to lead your organization towards a more sustainable path.